We're all watching this incredible arms race to build bigger and bigger AI. But what if the next giant leap isn't about size at all? What if it's about strategy? Today, we're diving into a new framework called Spark that's teaching AI to work smarter, not harder. And it might just be turning the whole idea of AI training on its head.
All right, so here's our game plan. First, we're going to unpack the massive roadblock that's been holding AI agents back. Then, we'll look at the old, kind of clunky way they tried to get around it. After that, we'll introduce Spark's brilliant new approach. And of course, we'll look at the cold, hard data that shows it actually works, and talk about what this means for all of us.
So, let's get right into it with the core challenge. They call it the AI exploration problem, and it's the exact puzzle that Spark was built to solve.
To really get a feel for this, just think about how you learn something new. Let's say you're trying a complicated recipe for the first time. Every single step doesn't require the same amount of brain power, right? Some steps are totally trivial, like opening the fridge door. You don't even think about it, it's automatic. But then you hit a snag. The recipe calls for eggs, but there are no eggs in the fridge. Now that's a critical moment. That requires real problem solving. Do you run to the store? Do you find a substitute? AI agents face this exact same kind of dilemma. And that brings us right to the heart of the issue. The big problem with a lot of current AI training is something called indiscriminate resource allocation. Basically, the AI wastes a huge amount of its energy and compute power on the easy stuff, the no-brainers, and doesn't spend nearly enough time exploring the really hard parts of a problem. So if that's the problem, what's the old-school solution? Well, for the most part, it's been something you could call a chain-like search. And honestly, it's a bit like forcing the AI to explore a maze with blinders on. This image really says it all. Over on the left, that's the traditional way. It's a single, rigid chain of thought. The AI tries one path to solve the problem. If it fails, it goes all the way back to the start and tries another single path. It's just brute force. And as you can probably guess, it is incredibly inefficient. And here is what that inefficiency looks like in practice. It's almost painful to watch. This agent needs to find an egg. It checks the fridge, checks the table, checks the microwave, no egg. So what does it do? It checks the fridge, the table, and the microwave again and again. It is completely stuck in a pointless loop, totally unable to think outside the box. So how do we break the agent out of that loop? Well, this is where Spark enters the picture. It's an entirely new strategy that gives the AI the insight to know when it's time to stop, take a step back, and actually think harder. Now, Spark stands for Strategic Policy-Aware Exploration via Key State Dynamic Branching. Yeah, it's a mouthful, I know. But the key ideas you need to remember are right there: strategic exploration and dynamic branching. Instead of just one path, it branches out to explore a bunch of options at once. But, and this is the important part, only when it really matters. Here's the four-step dance. First, it kicks things off with a few different starting ideas, just to get some variety. Then the magic happens: autonomous branching. When the AI gets stuck or feels uncertain, it decides all by itself to branch out and try a few different things. It does all this while staying on budget, computationally speaking. And then, finally, the most crucial part. It learns from all of those branches, the successes and the failures, not just from one single attempt. Okay, so how does it know when to branch out? This part is seriously clever. The agent is actually trained to put a little tag, an explore tag, in its own internal reasoning. You can think of it like the AI raising its hand and saying, hey, wait a minute, the obvious plan isn't working. I need to think about some other options here. It's a signal of its own uncertainty. So let's go back to our agent who couldn't find the egg. The SPARC agent checks the usual spots: fridge, table, no egg. But instead of getting stuck, it generates that explore tag. That triggers it to think of other places an egg might be, like, say, the kitchen sink. It explores that new branch, and bingo, it finds the egg and finishes the task. No loop, just smart, targeted problem solving. Okay, the theory sounds fantastic, but talk is cheap. Does it actually work? Let's get into the numbers, because the data here is pretty spectacular. This chart really speaks for itself. Across a whole bunch of different, really complex tasks, everything from navigating virtual worlds to scientific problem solving, Spark just consistently blows the other methods out of the water. The other bars are the older techniques, and as you can see, Spark is the clear winner across the board. And we're not talking about a small improvement here. When you average it all out, Spark delivers a whopping 73.5% performance boost over those older methods.
That isn't just a step forward, that is a giant leap.
Now this is my favorite slide. It's a true David versus Goliath story. The researchers put a pretty small model, just 1.5 billion parameters, trained with Spark up against a massive model. And on a super complex scientific reasoning task, the smaller, smarter Spark agent didn't just hold its own. It won by a lot. It proves that a better strategy can beat raw power.
And if being smarter wasn't enough, Spark is also ridiculously efficient. It gets these amazing results using only 20% of the training data that the older methods need. That's a 5-fold improvement in efficiency. We're talking huge savings in time, energy, and money.
So let's pull back and look at the big picture. Why is making AI this much more efficient a total game changer?
Because Spark is more than just a clever piece of code. It's really a new philosophy for building AI. We're moving away from telling an AI exactly how to learn, and we're starting to build systems that can figure out for themselves where to focus their own brain power, a lot more like how we humans solve problems.
So what does this all mean for the future? Well, it means AI development gets cheaper and faster. It means we can use smaller, more accessible models to solve enormous problems. And maybe most importantly, it means we can build AI that's better at adapting to new things it's never seen before, because it's actually learned how to think. The researchers who created it summed it up perfectly. They said, "Our work highlights strategic exploration's value in advancing capable and efficient agentic systems. In simple terms, it's about making AI that can act more independently and intelligently. It's about making AI that's both more powerful and way more practical." And all of this leaves us with one massive, exciting question. Now that we can build AI agents that explore the world with a strategy that looks a lot more like our own, what are the next grand challenges we can set for them? From discovering new medicines to designing better cities, the possibilities are just starting to branch out.